We're going to talk about applying the Pythagorean theorem in real-world problems. So what's important to remember is that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So let's look at how we can apply this theorem, the Pythagorean theorem, to real-world problems. So in this first example, it says, Bethany has a circular tabletop that she needs to carry inside her house to paint. Her front door is a rectangle and has a width of 36 inches and a height of 80 inches. If the tabletop has a diameter of 86 inches, will it fit through the front door? Okay, so what I know that I have a rectangular door, right? And I know the dimensions of my door are 36 inches in width and 80 inches in height. Okay, that's what I know. I also know that I have a circular table. So here's my table. Okay. And I know that my table has a diameter of 86 inches. Now remember, diameter means all the way across your circle. So my diameter is 86 inches. Okay? Now, it's asking if the tabletop will fit through her front door. Well, if I were to put this put this table through the door, it's too wide to fit sideways, and it's too wide to fit going in long ways. So we need to figure out how can we fit it in. Well, I have this diagonal right here, which is the longest part of that rectangle. Okay, this is also making two right triangles, so therefore this diagonal is actually the hypotenuse. So now I know if I'm looking for this diagonal length right here, I'm also going to use my Pythagorean theorem to find this diagonal value right here. I need to know, is the diagonal distance greater than 86 inches. So if this diagonal is greater than 86 inches, I can fit this table through that door. And if it is less than 86 inches, my table won't go through that door. Okay? So I'm going to redraw my door right here so we can see it bigger. Okay, I have my 36 inches here. I have my 80 inches here, and I'm looking for this value right here. Okay, so if you remember, we used that a squared plus b squared plus c squared. I'm going to label my parts. So I'm going to say a is 36, b is 80, and I'm looking for my c value right here. So now I just use a squared plus b squared equals c squared to solve for c. Now I'm going to substitute my values for my a and my values for my b into my problem. A is 36, so I have 36 squared, plus b squared, my b is 80, so I have 80 squared, equals, I don't know the value for c, so I'm just going to leave it c squared on that side. Now I can go ahead and figure out what 36 squared is. Now I use my calculator, I plug it in. 36 squared is equal to 1,296 plus 80 squared is 6,400 equals, I still don't know the value of c, so I'm still going to leave it c squared. Then I'm going to add these two values together. So 1,296 plus 6,400 is equal to 7,696, and that equals c squared. Now I'm looking for c, not c squared, so I need to cancel out this squared, and the way I do that is I take the square root of c squared to get c, but if I take the square root of one side, I also have to take the square root of the other side to balance it out. So the square root of 7,696, you plug that into your calculator, and I got 87.73. So that means this value right here is 87.73 inches. So, my solution, will the door fit? Well, is my diagonal distance greater than 86 inches? Yes, my diagonal distance is 87.73. So, yes, the table will fit through the door. Okay, let's do one more example. So on the bottom part, now we're talking about a baseball field. Okay, so Greg plays baseball at a field where the baseball diamond is a square with each side of the square measuring 90 feet. If the baseball was thrown from home plate to second base, then from second base to third, how many feet did the baseball travel? Round to the nearest tenth. All right, so I know that the baseball field is a square, like this. Okay, if you're not familiar with baseball, you have home, first, second, and third, right? And then I know that each side of my square measures 90 feet. Then it says the baseball was thrown from from home to second base, and then from second base to third. So we didn't just throw it one time, we threw it twice. How many feet did the baseball travel? Well, if you look, I had a square, but whenever I threw from home to second, I cut through my square. I found my diagonal, and that diagonal, creates your hypotenuse. It creates a right triangle. So really, I need to know that my diagonal is my hypotenuse, and then I can use a squared plus b squared equals c squared to find the distance from home to second. What I need to know is the total distance from home plate to second base and from second to third base. Okay, so I'm going to draw my baseball diamond a little bigger so we can have a better look at it. Okay, so remember this is home, first, second, and third. I know that I'm going to be throwing from home to second, and that creates a right triangle. I also know that the side lengths of each from base to base, so from home to first, first to second, second to third, third to fourth, is 90 feet. So I know this value right here. I know this value right here. Okay? So I need to know this distance plus this distance. Well, I don't know what this distance is, but since I have two legs of my right triangle, I can find this distance using Pythagorean theorem. So I'm going to call this A, I'm going to call this leg B, and I'm looking for my C value right there. Okay, I'm going to use Pythagorean theorem, so A squared plus B squared equals C squared. And now I just substitute in my values. So my A is 90, so I have 90 squared, plus my B value is also 90, so I have 90 squared. I don't know my C value, so I'm going to put C squared. Then I use my calculator. 90 squared is 8,100. So I have 8,100 plus 8,100. I still don't know my value of C, so I just put C squared. Now I add these two values together, so I get 16,200 equals C squared. I don't want C squared, I'm looking for C, so I need to take the square root of both sides. The square root of 16,200 is 127.28. That equals C. So this value right here, this distance from home to second base is 127.28 feet. Okay? Now remember, I am looking for the total distance from home to second and second to third. So I'm going to add these two values together. I have 127.28 plus my 90 feet, and I get 217.28 feet. And that is our solution, 217.28 feet. Okay, so we just applied the Pythagorean theorem to real-world problems. On the back, there are some practice problems. You need to complete all the problems on the back.